development. He's a renowned consultant to many industries in India such as Rane Group, TVS Group, Thermax, Shanti Gears, Precol, Texmac Industries and many more. He's a managing director of EGS Company, Computers India Private Limited since 1993. His areas of expertise include geometric dimensioning and tolerancing, dimensional management, design for quality, design failure modes, value analysis and value engineering, design for cost, product design development. He has carried out very many successful projects with many brand names across the globe and has been a certified ASME GDTP technologist in the past by undergoing his certification as well.
Specifically in their domain areas, and we would love to hear from them, share their knowledge with all of us who are here. And the two gentlemen are Mr. Sebastian Sutter, who is the head of international business in SIMCON, Aachen, Germany, with over 15 years of experience in the field of software-supported injection molding, plastic injection molding, design, leading projects in multiple industries. Before joining SIMCON, he had got his bachelor's degree from Aachen University at Applied Sciences. His thesis focused on the influence of material batch fluctuations on the injection mold process using simulation as the mainstay. It's important for us to understand that when we are going through these kinds of product development and new technologies which are emerging from the field, simulation becomes a mainstay in upfront engineering, primarily to get things right the first time. So we welcome you, sir, with regard to this. And then we have another distinguished person, Mr. Dhiruj Sarda, an electronics engineer turned into a marketing and technical expert in the field of magnets used for work holding applications in the CNC machines and lifting applications in steel plates. After inception of East Coast Magnets Private Limited in 2000, he headed both production and marketing department and has been very active in taking the products to a whole new level. With over 2 decades of expertise in developing several patented products, we welcome him on board to share with us his knowledge and how this community over here can benefit from his experience and wisdom. Please give a round of applause and let's get started with the presentation. Over to you, sir. Please go. First up. Thank you.
Good afternoon, ladies and gentlemen. Thank you very much for taking the time to be here today. For me, it's a big, big pleasure to be here at this great seminar hosted by the IPI. I was in 2020 already able to give a webinar together with the IPI, and now it's my pleasure to be here in person as well with you. Thank you so much. Thank you. Okay. Yeah, so I would like to talk to you today about goodbye trial and error simulation or part and mold design and hello rapid variant analysis. With the words of today's keynote speaker, Mr. Senthil Kumaran, he talked about digitization as one of the most important points in the future in injection molding, but also other topic or other fields, of course. So that's why we would like to go ahead and start with a quote from an engineer working in the injection molding field. Part and mold design isn't stressful at all. It's something Peter, age 27, is quoting. So like you can see, he seems to be doing it still in the trial and error way and not in the way like we would like to do it. So maybe before we go into the field, some facts and figures about company SIMCON. Company SIMCON was founded in 1988 as a spin-off of the IKV. You already heard this name today. The IKV is one of the most famous plastic institutes worldwide, located in Aachen at the RWTH, and we are located in Würselen, which is just 5 kilometers ahead from the away from the university. Just 2 days ago, there was the IKV colloquium, so one of the most famous, let's say, seminars as well in Germany for the plastics industry, where of course we took part as well. So we are more than 34 years in the market, like you can see, having a lot of experience in injection molding simulation and injection molding optimization. Worldwide, we are serving more than 6,000 software customers, and we are not only a simulation software provider, but also a simulation service provider. So that means together with our partners worldwide, we have done more than 12,000 projects for very well-known companies and solved their injection molding issues, and yeah, that is what we do. Oops, sorry, wrong direction. So, like you can see on this slide, just to give you a quick reference who's using our software, like you can see many global users or leaders are already using the solutions. You see companies like Bosch, like Continental, like Titan, like TE Connectivity, Arberg as one of the injection molding machine suppliers. So you can see we have a wide variety of users, from part engineers to mold designers and mold engineers to quality engineers, and also of course the injection machine users itself. That is who is using our software. One thing which is from our point of view, for us of course very important, is the fact that our software is fully made in Germany. Why is it important? I guess all of you have already worked together with German companies, with German partners, and what are they? They are quality obsessed. Yeah? So if one thing is important in Germany, then it is quality. And one thing which is more important is, if the quality is not okay, they will tell you. They will tell you. And so that means with all these customers in Europe, in Germany, using our software, from the OEM down to tier 1, tier 2, and so on, we have very critical customers. And if our quality would not be okay, I would probably not be here today, and you would not be listening to my speech. So we heard this morning already something about front loading. So front loading is so important. Front loading is one of the most important things you can do when you're talking about product design, mold design. So doing one simulation, maybe when the mold design is once finished and you are going into production, that's much too late. So then you're too late with your simulation. So it's better if you start with your simulation as early as possible. That means best case would be early in the part design stage. Why? Because when you're already in the sampling phase or in the tryout phase, it's much too late. So all changes will be very expensive, because you will have built to create a new mold, you will need to change your mold. So every physical change is very expensive and is too late and causing a lot of issues. Yeah? So therefore, we should move this point of using simulation much more upfront in the direction of the virtual stage. What we heard already, we heard that 18 months of the development of a car are in the virtual stage, 18 months are in the physical stage, and so that is something, if you want to reduce this, to cut this down, you need to start with your simulations very early, so better solve the issues before you go into the mold design or mold production. So we call it like, don't be a simulator. So, and what is more important, we will see it in the later slides, simulate early and simulate often as well. Don't only simulate once. I have some questions for you. So you can see here some questions. What would you most like to improve in part and mold engineering? And now you can maybe just raise your hand when I read the answers. So about the filling behavior, air entrapments, weld lines, short shots, who would like to improve this? Nobody. Everyone is fine with his products concerning filling, air entrapments, weld lines. Never had these issues. Okay, that's great. How about shrinkage and warpage? Is that any challenge for you? For whom of you is it a challenge to have shrinkage and warpage solved? At least one is raising his hand, so yeah, proud to see this. How about cycle time reduction? When we talk about increasing costs of energy, increasing costs of material, what is about saving some cycle time to save some revenue? No one? No one is, everyone is fine with the cycle time? Wow. Okay. You want to save some time. And then we have some more times, like save time and capacity in the engineering, which should be very important, and some others. Second question from my side is, how do you presently find or explore better solutions? Who is still just going by his experience and not using any simulation tool yet? Is there anyone not using any simulation tool? You don't need to be afraid, just raise your hand. Okay, that's good. That's the first step, to use simulation. Second step, do you compare widely multiple simulation results, or do you just do one simulation and then it's okay for you because you have the result? Seems not to be, okay. Who uses DOE? Who uses DOE to run his simulations? 1, 2. How do all the others do this when they don't do just multiple simulations? Okay. And who is using simulation with dynamic interactive results? Oh, nobody. Okay, then maybe I have something for you. Okay, so then let's go ahead, because then I have something for you. We have, let's say, 3 stages in the product development, mode design stage where we support with our solutions. First solution, CAD mold. CAD mold is our initial start where we find the first simulation, find out basic issues, get the basic design right, and uncover the main issues, I would say. Though that is something you can do also with competitor softwares, like you all will know who they are. And then we have a tool which is called Varimos. Varimos is our tool for a rapid variant analysis. I will go into detail later. So that is something to try many options, to finalize part and mode design, and to pre-optimize the injection molding process itself as well in a virtual stage. And then we are at the stage where we cross the mold building process, so where we go into mold building and first tryouts, and there we have a solution as well, which is called Varimos Wheel, and Varimos Wheel will enable you to validate, enhance, and finalize. So that means you can do a DOE on the machine, get the best parameters, and get the best parts in the best cycle time, for example. That is something where we don't want to focus today. Today we want to focus on the virtual stage because there's much more gainings than in the wheel stage. So let's focus on CAD mold. I would like to give you some examples, just some basic information, because all of you said you know already simulation, you're using it, so I will just give you the basic information and then go into the optimization. So you can see our software is calibrated through more than 30 years of real-world usage. Here just one example, how good the filling for a part with all kinds of different shapes is working, how precise it is. So you can see round corners, you can see sharp corners, you can see all the different kind of wings you have. And so you can see real world, short shot, and the short shot from the simulation are matching perfectly. Then we have a second example. This example is also interesting because it was done already, I think, more than 5 to 6 years ago in a project where we discovered the behavior of natural fiber compounds. So it was a project together with Ford and the University of Medicine to simulate fiber orientation for natural fiber compounds, which is today getting more and more important to replace traditional materials. And you can see again in the short shot studies from the simulation and in the real short shots how good the simulation is predicting the position of the weld lines and showing the filling behavior in general. Yeah? So also that is something what is possible with simulation today without any issue. We talked about fiber orientations. We will later talk about this again, but so handover to structural solvers to crash testing is not any issue nowadays. Yeah? So you can see here the simulation of it. For also a glove compartment cover done by a PP with natural fiber. Next one is, of course, one topic which is very important for most of you, or for all of you, predict and solve shrinkage and warpage. And what is important, if we talk about shrinkage and warpage, that you have precise simulation results. And here, when you look at this example, and you see the simulated warpage in the left upper corner of the colored part, of the simulation part, you can see there's the maximum deviation. It is 3.4 millimeter in the simulation, and 3.5 millimeter on the measured part. And we have a part which has a size of nearly 400 by 350 millimeters, so it's a quite large part. And this accuracy of 0.1 millimeter is very good for this kind of difficult part. Then one other challenge you might have are on Class A surfaces. You will have sink marks, which you will hopefully not have them, or you don't want to have them. And so you can see here, for example, CAD mold can predict the depths of the sink mark in a very precise way. Left side 0.23 millimeter for the simulation, right side 0.25 millimeter for the simulated part. So for example, we have in Germany a lot of customers who are doing chrome-plated parts and are relying to our simulation to predict whether they have issues after the chrome plating or not. Then we see, for example, here a very interesting part. I am only allowed to show the plastic part, not the full, let's say, component where it's belonging to. So it's a electrical bike, an e-bike. Yeah. So it's a frame, or you can see the half of a frame completely done by injection molding. And here, this the special application was injection molding by sequential injection molding or cascadic injection molding, and also that is possible to be simulated. Next slide is about the thermal behavior of the mold. Also, that is something what is possible to do. So if we're talking about the mold designer, the mold maker, then we have for him a tool to detect hotspots, to detect areas where maybe a conformal cooling insert might be needed, where maybe a high heat transmission material might be needed. So you can see the thermal behavior of the mold as well. One interesting topic which might also come into the field when it's about light-white technology. So we have the foam module for physical and chemical foaming. So you can simulate all parts with physical or chemical foaming. You can see what is the savings in the white, what is the behavior in the filling, because the viscosity of the material will change due to the foaming agent. And you can see, of course, the shrinkage warpage behavior. One part which we did recently in a project together with Fraunhofer, Heller and some others is a LED headlight lens. So that is the lens for an LED headlamp. And the interesting process is that it is injection molded by 3 layers, PMMI and PMMA together. And so that is something what was developed in a really interesting project to make this available for the new light generation. So just to finish this topic of CAD mold is a modular structured software, so you only need to license or to buy what you need, so you don't need to buy any modules you don't need. So we have modular structure for all of our topics. So now let's come to the very interesting point, to the more important point, which is Varimos. So Varimos should help you to improve faster. The rapid variant analysis should support you to get out of many options the best result much faster than we can do it in the trial and error or in a normal way of simulating. What is important? It's important is that one simulation is never enough. It's not only not enough, it's never enough. Because if you want to find out any better solutions, you need to have more than one simulation. Yeah? So if you want to know what changes if I change any of my parameter, in what directions will the results improve or get worse, what is the best feasible solution really? And if you want to know the robustness of your part and your process, you cannot do one simulation. You should do much simulations as possible. You can do this in the good old-fashioned way, which means you do one variant after each other. So your engineer will do one simulation, will take a look at the results, will fine-tune the settings, and will do the next simulation. Takes a lot of time, it's depending on the user, so you don't know about the outcome, and it's an inefficient way. Yeah? So what our software Varimos supports you with is to do this in parallel. So that means Varimos guides the user how to set up these simulations in a very short time in parallel, what we call the rapid variant analysis. So that is something I will show you in the next slides as well, how it works. So the workflow is that you set up first initial simulation where you uncover the main issues, and then your user defines the parameters which can be changed. So that can be the filling time, the packing time, the process parameters. So it can be all kind of parameters of the injection molding process. But it can be as well the wall thickness of the part in certain areas. So the thickness of the whips, the thickness of a certain flow aid or flow brake, can be the diameter of the cooling channel, the diameter of the gate. So you have process options, but also geometrical options to use as a parameter. So that is something you need to define, and on the other side you define your targets. Targets can be the length of the part, the width of the part, the flatness, can be the clamping force, the cycle time. So all of these results which you can get out of a simulation can be a target for you. And then Varimos will compute these simulations automatically in CAD mold, so it will create a design of experiments, will run this automatically, will summarize all of your results which you have taken and learn by these results like an AI, yeah? And then show you to discuss and decide what is the best outcome, what parameter changes if you change, or what result changes if you change any parameter. How does it look like? We'll have a look at the cockpit, which is inside Varimos. So on the left side, you can see the variables, so the settings or the control factor, which can be changed. On the right side, you see the quality measures, which you have defined, length, width, flatness, and so on. As long as the dot is green and inside the tolerance band, which you can see, you're okay. As soon as it moves outside, so let me go back to playing the presentation again. So you can see that moving the parameters or the variables, the targets will move outside, and clicking the optimize button now will bring all results back into the tolerances. Of course, not all of your projects, parts will always have 100% quality, but you will know this much earlier than during the trial stage. So you will know this before building the mold, and that is what is so important. So even if you have a result which is not good enough, you will know it early enough. Yeah? So not only 100% result is good, also a bad result can be good when you know it early enough to change things. And with Varimos, what is important to mention again, so you can serve multiple goals. Yeah? So you can serve multiple goals at once, have a what-if analysis within these tools, see the trade-offs between, for example, shorter cycle time and higher melt temperature, for example. And it's not a black box, because your engineer will define what is possible on the mold or on the part, and will define what are the targets you would like to reach. Because you can do this DOE maybe also in another system, but then maybe the quality criteria will only be maximum warpage. But maximum warpage, who cares about maximum warpage? You care about warpage on certain positions, about the flatness, but not on the maximum warpage, because that can be anywhere. So one thing which is important here is you should not wait days or weeks for these results, because then you can do it in a traditional way. So it means slow simulations here are a real time killer, and that's why CAD mold simulation is set up as a very fast multi-simulation tool. So that means we are already fast for one simulation. One simulation you can do normally 2 to 3 times faster than competitor software on the same hardware with the same quality of the results. But we have an approach where, especially running many simulations in parallel, 6, 8, depends on your hardware, will run in nearly the same time than one simulation. So that means when the competitors slow down, we keep the speed. And so that means that is a key fact why simulating and optimizing with Varimos, it's much more efficient than with any competitor tool which might do something similar, but they are not fast enough. So you will get results for a typical part on our side within 24 hours, within 48 hours, depends on the size of the part, of course. No. Let's come to a case study. So we have 2 case studies here. One is a case study by the company Brita. Brita is doing these water purification systems, for example, for these drink dispensers, which you all might know. We have here a pressure-sensitive part. We have a fiber-reinforced material. We have the challenge to do a rotation friction welding from the top and the bottom part with very tight tolerances. What we wanted to achieve here was we wanted to achieve a balanced filling, because in the initial simulation the part was not round, it was oval. An oval part we cannot rotation friction weld. Yeah? So therefore our target for a fiber-filled part was to have a uniform flow front. We can reach this when we are allowed to change wall thickness in some certain areas. So the parameters which were allowed to be changed are some wall thickness, like you can see here, in 5 different areas. And now the software was calculating in the background what is the best wall thickness distribution for reaching the best balanced filling. And you can see that here some changes on the geometry have been done by the software automatically based on the tryouts, or based on the virtual tryouts in the optimization software. And then the result was that before optimization you can see a non-balanced filling, and after optimization you can see a completely or perfectly balanced filling, which then led, of course, to a much better roundness. So if we see the roundness before, it is the wet bars, and the wet bars are outside the tolerance of 0.15. And you can see afterwards, after the optimization, you have a perfect roundness for the part. The friction welding was possible, and so you have no issue with the part. Maybe one second case. This second case was done by Odelo. Odelo is one of the leading companies for car tail lights. Yeah, so they are using our solutions for a long time already. And this example is about the latest A6 backlight or tail light. And the challenge here was we have a complex multi-component and multi-material part. So we have the back cover and we have the housing in different colors. And they need to be laser welded together. For this laser welding, there should be not any gap, because if you have any gap, you will not be able to do a good laser welding. And so the challenge was to have a warpage or no warpage, which allows to do the laser welding in a successful way. Initially, like you can see in the next slide, the warpage was too high to laser weld it. So they already built the mold, then they figured out that the warpage was too high, and you can see on the lower right corner and on the upper left corner that there are wet areas where the warpage was quite high. And so we did then an optimization with Varimos, only on the process parameter, because the mold was already built, and we tried to figure out whether the mold parameter or process parameter would be okay. And the result was that after getting better parameters from Varimos, the warpage was reduced, like you can see now, to a minimum. So you can see when the same color scheme is applied, no yellow, no wet areas, and so the warpage was okay to do a laser welding and to finally get this part on the road for this car. Beside that, they received the GKV Tech part, which is one innovation prize in Germany for this kind of part. So just one last example here to show you how much time you might be able to save. And so that means you have here the traditional way, which means doing it step by step, which take you about 200 hours. Yeah? And you have the new way, doing it with Varimos, which takes you only setting up the first simulation plus 30 minutes, and then having 26 hours of calculation time in parallel. So that means for the same project, you will be in less of 30 hours on the same or better result, even better result than with the traditional way. So one last thing, a software is only as good as the user and as the process behind it. So that means the process is also very important. So we see better together approach. So that means you should use the software as a tool to communicate between the different departments, from supplier to vendor and so on. Because only if you involve CAD design, rheological department, machine setters, metrology early enough, you can save or you can win a good part. Therefore, it's important that the software is compatible with other solutions. For example, to be able to import any native CAD file by default without any extra cost. To give results to structural solvers like ANSYS, Abacus, whatever. To give results to a crash simulation. We are able to export our results, for example, to PEMCrash, and one of the German OEMs is using it, CAD mold results, together with PEMCrash, to do an early crash simulation based on fiber orientation as well. Then we have connections to injection molding machine suppliers like Arburg or Engel, for example, so they can run our software on their machine. And a connection to the metrology department. That is something what is properly shown here. So first of them is Engel Simlink, so we can exchange parameters from machine to simulation and vice versa. And the second step is here that with Varimos, CAD mold and VG metrology, you can measure in the same way on the virtual part than on the physical part. So we take the same quality measures for both approaches, for real parts and physical parts, and that is something which is really important when you want to have the complete chain covered. So I think two last slides probably, because that is something we already mentioned. You can see we have a very high rate of innovation, so that means already in a very short time, we have very new, interesting features like a 3D V simulation, which is enhancing our capabilities in really thick parts. We have, for example, the interfaces to PEMCrash and volume graphics. We have a plus 50% solver speed, new material database with bio-based polymers and so on, and new functions to come very soon. And of course, many of you will be decision makers, management position, show me the money. So we see typically saving our customers 25 to 50% of correction loop. And that means when we are talking about 18 months of development time in the practical phase, you can reduce this a lot by saving any kind of tryout, and so you will get shorter, of course, in these areas. So I think the gentleman from Kingfa already invited you to the K-Show. I would like to do the same. So we are, of course, at our home turf in Germany, available on the K-Show, stand E17 in Hall 11. So please give us a visit if you visit the K-Show in Germany. It would be a pleasure to have you all there. And we are looking for a great show after so many years of pandemics where we don't have these great shows. And so, yeah, we are really looking forward to it. And if you are too busy to improve, of course, it's your decision, but please think about it twice, because you can never be too busy to improve, because it will pay off that you do it. And I will close with this slide, because as a sportsman, if steroids are illegal for professional athletes, shouldn't Valmos be it as well for users of a simulation software? No, it's not. So please use it, and please don't be afraid that you use something which is illegal. Thank you very much.
Thank you very much. That was an excellent presentation, specifically in the area of simulation of molds and processes before you take it and start developing the prototypes. Very informative indeed. Now I invite Mr. Sarda to come over and give his presentation. Thank you.
Namaskar, gentlemen. I'm Dhiruj Sarda. Can you start the presentation, please? So I hope everybody had a good lunch and not too sleepy. Yeah. So I'm Dhiruj Sarda. I come from the company East Coast Magnets Private Limited. I'll start with our story. So our story started 62 years ago by my great-grandfather. I'm fourth generation. And we started our manufacturing story in Kolkata in 1960. 1978, we started manufacturing electromagnets. And then we moved on slowly and steadily, catching up with technology all over the world. And the first time we produced our first electropermanent magnet, which was a very new thing in Europe, was in 1988, sorry. We have been exporting all over the world for the past 40 years now, with customers in Germany, Japan, Korea, US, Brazil, Singapore. And our primary market is Germany. So as the speaker before me emphasized that Germany, and why Germany? Because Germany relies on quality. So we not only have German customers, my biggest is German, the second is Japanese, and the third is Korean. So they really tighten us on quality and reliability and everything. We were following technology till 1999, and then we started developing our own technology. On 2002, we filed our first patent, and then on we have got now 10 patents in magnetic work holding and lifting technology. All this without any foreign collaboration. It's 100% Indian, and we are proudly making it in India. We started manufacturing in Hyderabad, and then we have set up another unit in Sri City to expand our manufacturing facilities. In 2022, we have more than 50,000 installations all over the world of our products, which we consider as an achievement, because that's a target we had set up in 2000, that we should have this. Now, our capabilities. We have a manufacturing facility in Hyderabad, which is 2,000 square meters. It's quite a small facility now. And we provide customized solutions for work holding and lifting. We have a facility in Sri City, which is a modern facility with present capacity of 8,100 square meters, and to be expanded to another 8,000 square meters over there. Now, our product range. So for the past 60 years, the only thing we have been doing is we have been producing magnets. All we know is magnets. Whether we want to hold steel, lift steel, separate steel, we do it with magnets. And as we were users of machining centers and surface grinding and turning machines, so our focus had been always towards that area. And so we have a lot of product development, customized solutions in work holding and clamping. Then off late, a lot of customers demanded that why don't you get into the injection molding business, because that is where more process optimization is required, time saving is required. And in 2019, we first set up our first installation for injection molding magnet with our patented technology. And so our focus, our whole concentration and focus is towards providing customized solutions to customers. We do not offer vanilla solutions. We do not push our solution. We meet customers, understand their problems, and try to solve their problems in the most cost-effective manner that is possible at our end. Now, I'll be elaborating about our technology, which is electropermanent magnets. So EP Press, that is a product for injection molding machine. We call it the fast mold clamping system. The technology is very simple. We take a magnet, we attach inducing steel poles, we charge the magnet, and when you bring your job, the magnetic field flows through the job and it gets clamped to the magnet. Primarily, this is a very simple way of explaining how this technology works. So we charge the magnet, and to charge the magnet, you just need a pulse of current for 2 milliseconds. And that is the only amount of time electricity is consumed by my product. So it's highly energy efficient. Once the product is charged, your product is clamped. It does not need any continuous support of electricity to hold it while it's in operation for an infinite period of time. Only again, to release the job, you need to discharge the magnet. So this technology has been quite old. We have developed it in India, and now what we did was, we patented the design. So all the earlier products that were available in the market had the top surface had a magnetic and a non-magnetic separating surface. So it would have steel, brass, steel epoxy, steel, stainless steel. What we did was, we made the whole top surface of a single piece of steel. How does this help the customer? It gives more structural stability. It does not allow any foreign material of any kind to enter the product from the front side, which means your product's life cycle is much longer. Especially in a lot of applications where a lot of heat is generated, the whole surface itself acts as a heat sink. So it kinds of reduces your operation temperature. Especially we have observed this in very thin part machining, where they are machining and due to the heat generation, the parts used to get warped. That has reduced drastically with our technology. And this was our first patent, and after this we have several other patents in sensing and measuring the magnetic field and other things. Now coming to the injection molding magnets. Primarily, injection molding magnets are two parts. One is fixed on the moving side, and the other is fixed on the stationary side. The features of our construction is, again, it's made of a single piece of steel, so structurally it is much stronger. It's a full metallic surface, so it's much more rigid and much more precise. There are no resin, non-magnetic material on the top surface, so it gives you better performance when exposed to higher temperatures. The bidirectional technology gives better stitching of the product, so it's clamped in a more uniform manner. All the products come with proximity sensors, heat sensors, and flux sensors. They're all standard, so we don't give options on safety. They are compulsory features in our products. The controllers come with HMI. They can be integrated with the machine, and they are Industry 4 ready. So we make it much easier for the customers to integrate it with their future requirements. Rather than trying to go and then ask, do you need this? We come upfront and say, we have this, and we are not ready to compromise on the safety and reliability of the solution. A typical setup is the magnet is clamped. You bring your mold on the stationary side, switch on the magnet, then bring on the moving side, switch on the magnet, and you start your molding process. It's a very simple process. The time here, what we save, in some cases, customer comment that the time saved is not much because we are using hydraulic clamping, which is very fast, or my mold size is small. What we offer is uniformity. Every time, 100%, you'll get exactly what you are asking for. So you're not dependent on hydraulic pressure, pneumatic pressure, mechanical force, nothing. A magnet switches on, it clamps. A magnet switches off, it releases. There is nothing in between. Disruption in power, disruption in any kind does not affect the magnet's performance. And yeah, so all our magnets are designed to take the mold weight on either side. So for any reason, if it happens that your mold's stuck and you open, so the magnets are designed so that the whole mold weight can be taken on one side of the magnet instead of being just distributed on both the sides. Technical features, as I've explained, it's full steel, monolithic construction. The thickness of the magnet varies from 50 millimeters, so you lose a daylight of 100 millimeters on your machine. Maximum temperature, so our standard temperature offering is 120 degrees, which means that the surface of the magnet can go up to 120 degrees. We have options for 150 and 180 degrees also. Then supply specifications, so all the magnets come with proximity sensors, heat sensors, flux sensors, HMI controllers. And as a standard in our controller, you can store up to 20 mold data. What I mean by 20 mold data is mold size. So you can define your mold size. The magnet calibrates the magnetic force it is going to generate if the mold is in touch. And when you do the operation and when you switch on the magnet, it compares the data. Whether the magnet, if the job has a dent or there is a gap, and if the field generated is less, it gives an alarm and it does not allow your machine to operate. So for any reason, if the mold is not clamped properly, your machine does not operate. It's interlocked with the machine. The safety feature, we have MFD, which is magnetic field detection. We have overcurrent detection, undercurrent detection, temperature sensing mechanism, integration with the machines on Euromap 70.1, 70.0. And we have something which is called ADPREM. It's an acronym. We say Accidental Demagnetization Prevention Mechanism. So even accidentally, when your machine is in operation, you cannot demagnetize our product. Only when your machine is stationary, not moving, only then you can demagnetize your product, our magnets. And we also give a mechanical mold protection, mold fall protection hook on each platens, so that if you still feel you need a safety mechanism on your mold, you can put a chain and a hook. Our pole configuration, now magnets are defined by poles. So if you've used a surface grinding machine or a milling machine with a magnet, you see you've got the pole, the fine pole, square pole, round pole, rectangular pole. So we offer a whole variety of pole configuration depending on the requirement of a customer, instead of just forcing our rigid pole configuration that I'm going to have only X design. All our designs are custom built, custom designed. So depending on your machine, the mold, and your application, we design the product and offer a solution. The magnets can be designed to operate on a variety of voltages, whether it is 220, 380, 440, 480, 400. Our controllers can be designed to work on any voltages, and similarly, the magnet is designed accordingly to give the most optimized utilization. We try to accommodate as much as possible on the requirements of the customer as far as the input voltage is concerned, rather than asking you to put a special transformer for my magnet or a special arrangement. We try to accommodate as much as possible with the supply that we get. Now this is a typical installation on a 1400-ton machine at an automotive OEM. So their requirement was, apart from the magnet, they said sometimes we get molds where we have non-magnetic surface on the back, or the mold is much bigger than the magnetic area. So they requested for T-slots on the magnet. So we did provide them with T-slots. So you can see the slots on the side beyond the square-shaped magnetic post that you see. And as you see, the whole surface is made of a single piece of steel. This is on the moving side. Again, the ejector holes are made as per the customer requirement. We try to accommodate maximum number of ejector holes so that a variety of molds can be used, present and future. So you don't need to, change your ejector hole configuration because the holes are not there in the magnetic platen. It's a small video on an installation at a 1400-ton machine. Can you speed up the video, please? So you locate the mold on the stationary side. Locating rings are provided. Again, these rings are provided as per customer input. So the ID of the ring is designed as per customer input. You bring it approximately 0.2 millimeter. The controller indicates that the mold is close enough. You switch on. Then you bring the moving side. 0.2 millimeter, and then that's it. The mold is there. Initial checking of mold, and the production starts. I'm sure the robot suppliers can help the customer take off their components faster. This particular customer is a die mold maker, and this is their testing machine. So they test a variety of sizes of molds. So they have a bigger machine, they put smaller molds, larger molds. So we designed the magnet accordingly so that they don't have to change they can use smaller and larger molds on the same machine rather than move molds on different machines. You see there's a second mold over here, which they are using. This is still a smaller mold than the earlier one. Can we go to the next slide? This one's for a larger machine. No, next slide. Next one. Next slide, please. Let's change the video. Oh, it's okay. We'll run this. So normally, a lot of customers who are using magnets, they prefer it on a larger machines, 850-ton and above machines. We have a customer in Chennai. He requested to give magnets on a 125-ton machine. So we were ourselves as sellers a bit confused that why do you want to buy a magnet on such a small machine? And well, he said the challenge is right now when I put a mold on a small machine, I have to continuously make a X amount of batch quantity because there is a time involved in changing molds. And he was losing customers who wanted very small batch quantity of his products. So with putting up a magnet on his 125-ton machine, his mold changing time is so fast that he can produce for 1 hour on a mold, change, put another mold, produce another set of parts on the same machine. And right now I can say he has 4 installations and he has ordered for 4 more. So what I'm trying to say is the conception that magnet patterns are only helpful when you have larger machines is not true. They can be useful on smaller machines, and this customer designed his business operation with magnets so that he can produce smaller batch quantities for different designs on the same machine rather than wait. So yes, the magnet, if you look at the cost of the magnet as per the cost of the machine, it sounds high, but the customer makes money out of it, and that is why he's buying multiple number of them. These are the image of the controller. So depending on the requirement of the customer, we offer them non-HMI and HMI controller. So non-HMI controller gives you visual indications. HMI controller gives you digital indications of the status of the magnet. But the safety features remain the same. Whether it is temperature, proximity, magnetic field, everything remains the same. It's just the indication is different and the interfacing is different. What are the advantages of magnetic clamping? It's speed, flexibility, uniform clamping, consistent clamping. It's safe, very low maintenance. There is no moving part. Once you clamp the magnet, it's part of your machine. It's highly energy efficient because electricity is required for a very small moment of time. It's very accessible, so you don't have anything protruding out on the mold or your mold bases, so there are no damages to your mold bases. It's affordable because it helps you save on a lot of additional cost apart from time. And as Mr. Senthil Kumar mentioned, environmentally sustainable. So when we consume so little energy to operate, we are definitely environmentally sustainable, and we do not cause any pollution on use. And why select Rudra? So why? Because we are a 60-year-old company with experience only in magnets. We have a service team in India which can reach the customer and solve the problem within 24 hours and within 72 hours globally with our channel partners all over the world. We have our own technology, our own patent, and we understand the technology. We have a global support in Germany, Japan, Korea, Singapore, America, and Brazil. Flexibility, we offer customized solutions depending on the customer. And reliability, with our experience in 50,000 installations, we are confident that we can offer a solution where the customer will be satisfied with our product. And we make in India. We have multiple brands. Rudra Magnets is a new brand in which we are manufacturing and selling our new age products. Sarda Magnets, which carries our family name, has been with all our traditional products. And MagnaSlot is a range of products for our international market where we have brand neutral. So we have a lot of channel partners who use MagnaSlot as a brand, so to give a uniformity to the product range. We have the other product range is magnets for work holding. On machining, we can manufacture, and we have given solutions to really large machining centers and small machining centers. Lifting, the largest solution we have provided is to lift 100 tons of steel slabs, and the smallest ones are a few grams on a robotic application. Thank you for your time.
We had two different kinds of presentation, one from Germany, one from India, both working on innovative processes and technologies, specifically as applied to injection molding requirements, one on the simulation side, the other one on the manufacturing side itself. It gives us immense pleasure to look at these kinds of diverse technologies taking podium over here and sharing with us their knowledge and their wisdom with regard to how they have come about. It warms us even further when we look at Atmanirbhar Bharat and we look at a representative from our fellow countrymen providing us with the technology that he has indigenously developed or painstakingly over so many years, and being a forerunner in that particular area worldwide. Now, I would like to summarize before I take the podium for my presentation. The first gentleman talked about rapid variant analysis, how the Germans are quality obsessed. I repeat, how the Germans are quality obsessed. He took pride in saying that. We need to learn from him as well. Yes? Agreed? And then design, simulate, optimize, build molds, tryouts, and serial production. How, if you were to take up the changes subsequently down the line, it would end up costing you more as compared to upfront engineering. And then, don't be a simulator, was the slogan that he brought about. And we looked at case studies, we looked at the capabilities of the tools and technologies that he has provided in terms of warpage, in terms of robustness, how the robustness can be incorporated in the design process itself, and the design of experiments and the optimization of your molds based on the results that you get out of the simulation. And then we looked at the 3 product variants, followed by 2 case studies, which were impressive in their own merits, and how the awards were given to the customer primarily based on the simulation results that they had got about. Then we looked at Rudra magnets and their genesis 60 years ago, 3rd generation, right? 4th generation, my apologies. 4th generation, it's so heartwarming, starting from Kolkata and and being all over the world. And what warms me most is the number of patents that they have developed over a period of time, so that the IPR of the company is the wealth of the company. Money is one thing. Second thing is IPR, and IPR self-sustains the company more than anything else. I'll give you a small case in point, just digressing from this a little bit. A few years ago, I was looking at the turnover of Samsung versus Apple. The turnover of Samsung Electronics was $203 billion at that point in time, for 5 years ago, maybe. And Apple was $208 billion. How many products does Apple carry? Handful of them, right? How many does Samsung Electronics carry? Who is interested in Samsung Electronics sales more than Samsung? It's Apple, because of the usage of their patented technologies. I'm driving home this point primarily because we are, in India, we are new to the concept of holding on to knowledge and putting them to reuse for monetization. We need to do that as well, right? We are proud that one of our fellow countrymen is doing it. Okay. And not only the benefits, also the safety associated with this product, he emphasized upon it, and how the whole thing would not work if the clamping were to be insufficient in terms of the fields that are being developed, or any type of that. And then how hydraulics needs to be avoided in this particular case. It's a very beautiful USP. Though he said it in a very passing statement, he didn't want to probably negate the other option available on the table. Nevertheless, the amount of time you would spend in putting the hydraulic systems together is going to be more expensive probably as compared to putting his technology in place and making it work with you for a lesser cost. And then it's custom built, and every one of them he has emphasized that we are delivering a solution, each one probably unique for a particular application as compared to another one. And probably he is satiated by the fact that he gets satisfied by the numerous challenges that comes forth, both of them. Achha. So, see, one of the most important things in technologies is you acquire technology, you develop technology, you fine-tune the technology, other technology comes forth as a result of it. You may not monetize one technology, but the spin-off may help you in something but much better. That's the curious case of destiny. Let's put it that way. And then we looked at useful for smaller machines as well, and he showed the case studies, the video studies of all of the requirements, requirements they can meet. Now comes to the third presentation, which is supposed to be from me, inescapable. Let's go through and have a few minutes of enjoyment with regard to automation and 3D printing in continuous production processes. I think I'm constrained with the degrees of freedom without a microphone over there. I have a tendency to go to the center of the podium to talk. What you see on the screen is the tail light of a car, and you can look at the fit and finish of the beauty of the beast, which you're seeing in the background, right? As we go through this presentation, first we need to look at why do we need automation? Why do we need 3D printing? Is it really recommended for our kind of businesses? We have been doing business in injection molding for quite some time, in plastic production, in so many different areas, right? Plastics, we see them everywhere. People are saying they are cursing plastics. They are trying to push them out. But plastics are here to stay, one way or the other, right? And if you look at the landmines, the fills, the landfills, the plastics are being removed and recycled. Good for them, good for us, good for the economy, good for nature as well. So a lot of different industry segments where we see plastics all over the place. Now, what you see over there is not the fish that you ate. It's the fishbone diagram. Do I need an automation? Do I need a 3D printing? Your fishbone diagram with regard to your quality issues that your organization is trying to solve day in and day out would give you the answers. If you were to look at injection molding and you were to look at all the different reasons for which a part defect comes about. The cause and effect diagram, right? You will be able to see over there which are the ones which need automation, which are the ones which need 3D printing. Uncommon, huh? To look at this. You have to see, every technology is there to solve a problem. We started with industrial revolution, then we went through industrial automation, then information technology happened. Where are we today? Knowledge millennium. People who possess knowledge will conquer. People who don't will exist or may perish. So in other words, de-skilling is the name of the hour when it comes to automation, right? Innovation takes a backseat when you take automation. That's the flip side to automation. But still we want to do it, right? Why? Cost, time, and quality. So when you look at any part defect, anything that was defective when you produced it, or anything that was defective when it was reported by your customer, go back and do a fishbone diagram. You will see whether you would require to learn from usage of 3D printing technologies and or automation. Two uncommon methods to look at different things. How many of you use 7 QC tools in your organization? Show of hands, please. 7 QC tools, old conventional quality control tools. Good. They are problem-solving tools. If you use it, your company grows. If you are in sales, you use the 7 QC tools. If you are in manufacturing, you use it. If you are in finance, you use it. Uncommon, huh? Those 7 QC tools are used all over the place by a lot of different companies which are developing technologies, which are mastering technologies, which are putting technologies to use, reuse day in and day out. So one of them is the fishbone diagram sitting over here. Now, you will get another one which is called as the Pareto chart. Now, this gives you the 80-20 principle. What has this got to do with automation? What are the things which are reducing your cycle time? Increasing your cycle time. What are the causative factors? How they can be influenced by automation? How can they be influenced by 3D printing? Please take a look at it. The problem and the solution are staring upon on your eye. You need to just recognize it, that's all. Similarly, when you look at the histogram, you look at the cycle time or any one of the histograms with regard to whatever the causal factors that are coming in, the frequency, the downtime, so many things which are coming in. I'll give you an interesting anecdote. In automation, how many of you buy biscuit packets? You do, right? Good day. And what is it written on top? 33% extra biscuits. Did you ask for it? But the red tag over there enthuses you to buy that, right? So one of the guys in my office, he didn't open the bag. He looked at it, he counted the number of biscuits inside, called up the 1-800 number and said, 3 biscuits are missing. He didn't open it. They said, did you open it? He said, no. Okay. And within a week, 7 biscuit packets came delivered by Amazon or Flipkart, whatever. Huh? What is the cost of poor quality here? You got it, right? So what was missing there? Calibration of the machine which was looking at the weight of the biscuit sitting over there. One customer came back to you and told you, you gave him 6 more. He's going to check every packet that he's going to buy next time, right? Loss of trust. That was automated, right? I'm coming to the point. It was automated. The process of producing biscuits is automated. How many of you have heard about the Japanese story and the Gujarati equivalent of it, of the soap cover? You have heard of it, right? There were cartons packed with wrappers of soap boxes without the soaps inside, and they put calibrating equipments in Japan, while in India they kept a fan over there. Simple solutions to what you think are complex problems to solve. So automation solves a lot of problems, but it creates a lot of problems as well. I am not a baiter for automation. You need it. But you need to be calculative in where you put an automation when you bring in together. Why automation? It could be productivity. It could be complicated communication that resulted in automation needing to be there. It could be diminishing quality. There are two things which require attention in any product that we develop: reliability and quality. If the reliability and the quality of the products that we develop are going to be compromised, and human interventions need to be few and far between, go for automation. If the errors need to be minimized or eliminated, if the bias needs to be changed over, try automation. Maybe not full automation, but some amount, right? And then operational instability. Now, in the automation areas, there are quite a few areas where you can do automation: in process control, in dosing. I told you an example of dosing. Okay, in a different kind. Conveying, cooling, measurement and control, and assembly. See, 90% of problems which occur in products developed with plastics, without plastics, with an assembly of components which include plastics, are assembly problems. Fit finish, inability to create assemblies of similar types, where qualities are going all over the charts. Those kinds of things are what keeps us from moving forward. So if a component gets reported as defective, it's probably did not fit into the scheme of things in assembly. How many of you have heard about this company called Takata? Airbag manufacturers, right? What did they go through 5 years ago? A recall. Takata America closed to prevent themselves from, to insulate themselves from the lawsuits of the American users, because the airbags got deployed when the vehicle was in operation without an accident being in place. 52% of that company was owned by Honda, right? And over 70% of the vehicles were recalled because they depended on one company to produce it. And what did they do wrong? Change the sequence of assembly in an automation line without looking at the quality and reliability objective goals. So simple, so costly. So like that, a lot of different areas in which you can take the information directly with the IoTs coming into place. You can get all these information so that quality can be predicted up front. Predicted up front by using these kinds of tools and technologies, putting this information and seeing what if scenarios can be simulated. Similarly, with regard to automation of the assemblies as well. So in all these cases, you can go through automation. And then you do the measurement of the control parameters using your 7QC tools continuously and make sure that they are within the upper and the lower control limits. And then comes 3D printing, the two eyes of the coin. Why is 3D printing required? This looks like a new animal inside the room. We are into conventional manufacturing methods. We are providing services by developing products and technologies. Things are going to change. They are already changing. There's one company which has invented in 250 3D printing machines, and he is continuing to invest in more 3D printing machines because he is not able to meet the low volume production. What is it? Low volume production, not high volume production, gentlemen. And what does he get? He rules the roost because he is dictating the prices. Unconventional. And where is this company? Not in India. In the place where you would not see this kind of a company, United States of America. He is producing it for the rest of the world. From where? We are always brainstormed into putting together mass production units, right? See where he is making his money from, 3D printing. Now, whenever a concept comes into picture, you have to develop products, period, to test it out, to facilitate, to look at the fit and finish. Today, the demand for prototype development people is much larger than the mass production people. Why? There are not many there. Where does the money lie? This line. So don't put all the eggs in one basket called mass production. Get onto this bandwagon and make your money. Prototype development in robots. Look at the number of plastics which are going in there. Can't we do it using low volume productions in this case? Drones, all plastics, right? Prosthetics, replacement, made to order for every limb that was lost. Made to order for every limb that was lost. A person loses a limb, gets a replacement which was the same shape and size as it was before. Difficult, huh? What is the cost of this technology? If you were to provide this to the person who does not have the limb, how do you change life of those people? 3D printing. So why 3D printing? It reduces costs, shortens lead times, better products, bring better products to market faster. Look at prototypes, see if it works. If the market acceptance is there, ramp it up to volume production. Functional review, 3D printing is the way to go. You can either print the product or you can print the mold. Huh? You know how much it costs to develop the mold, right? Steel molds. Now here it is. Mold is coming from plastics. So for all these items, and then you can use it for testing, analysis, and review of shorter period of time. Now, you see this company, this is the company, Form Labs. What you're seeing is the machine sitting over there, low volume production. Imagine the amount of money you would spend in investing in a high volume production. Look at, this is nothing as compared to that. Now the molds, use standard metal frames, whatever you use, put the molds in, reduce your cooling time, and the only thing disadvantage is the cooling time, air sprayed, short cycle time, low cost parts, minor design modifications at the design stage, set the temperature to the lower threshold levels, injection levels to the lower ones, increase the duration, get it done. Do I care about cycle time in a low volume production? Every piece is money for me, right? Break the mold, guys. Break the cliches. Go and develop this. Put this together. Get money. The world is your market, at your feet. What you see over here are components, tools developed using plastics, unconventional methods, right? So what are the avenues of growth? You can, instead of doing only services in terms of producing components in large volume, go for prototype services. Put these kinds of machines. These are no-brainers. Low volume production services. People like TVS Motors will come after you, R&D department. Give me 200 bikes, components for them. Now I am going to Taiwan and Korea. Huh? Innovative new product development. You can develop your own products and technologies. Put it into the marketplace. Transform from services to product provider. The bottom line is, if you want to improvise, indigenize, and innovate, look for uncommon ways of doing business. Uncommon ways of looking at technologies in a completely different fashion so that the next generation of India can thrive much better than what it is today. Thank you.
We have to skip the Q&A. We'll keep it to the end of the next session. Gentle reminder on visiting the stalls of our co-sponsors. They are behind the hall. And there are also feedback forms, which I mentioned, so I request you to fill them as well as the lucky draw, which will be towards the end of the next final session. Now I request the mementos to be distributed to our dignitaries. Mr. Balachandra, please kindly distribute the memento to Sebastian Sutter, sir.
I left something, I'll just, sorry.
Mr. Muthukrishnan will now hand over the memento to Dhiruj Sarda. Mr. Suresh will now hand over the memento to Mr. Natarajan for his powerful presentation.
Overpacked presentation.
We will break for tea now, and I request you all to be back in 10 minutes by 3:30. Thank you.